Today we'll talk about physical measurement. Chapter 1, Lesson 1. First, what the meaning of measurement process? It's a process of comparing a known quantity with another known quantity of its same kind to find out how many times the first includes the second. What I mean by known and unknown, when I want to measure my length, it's called unknown. I bring a meter tab to measure it. So the meter tab is unknown because it's a weighted meter, okay? We have three key elements of any measurement process. First one is called physical quantity. Second, measuring tools. Third, measuring units. We'll talk about the first one that called physical quantities. Physical quantities are classified into fundamental physical quantities and derived physical quantities. First, what the meaning of or what the difference between fundamental and derived physical quantities. For example, for fundamental physical quantities, when I said my length is equal 164 meters, so you understand my length and you didn't need any other physical quantities to define my length. So the length is defined by itself. It's called fundamental physical quantities. When I said the time now is equal 2 p.m., so it didn't need another physical quantity to define the time. When I said my mass or my weight is equal 60 kilogram, so you understand what I mean. So it's defined by itself. So we can define the fundamental physical quantities as the physical quantities that can't be defined by other physical quantities. It's defined by itself. For example, length, time, and mass. Okay? Derived physical. Now we'll talk about derived physical quantities. When I said the volume of any of a cuboid is equal 30 meter cube. No, it doesn't define by itself because the volume of a cuboid is equal length times width times height. So to define the volume of a cuboid, you must know the length of a cuboid and the width and the height. So it needs other physical quantities to define. When I said the speed of a car is equal 20 meters per second, you must know the distance and the time to define the speed. Also, the acceleration equal 10 meters per second squared. You must know the velocity and you must know the time. So derived physical quantities, the physical quantities that can be defined by other physical quantities. For example, volume, speed, and speed and acceleration. Sorry. Okay. So first key elements for any measurement process, we must know physical quantities. Any physical quantities can be classified into fundamental and derived physical quantities. The main point or the main difference, the fundamental can't be defined and derived can be defined. The second key elements we must talk about measuring tools. Okay, in ancient times, man was using his body as tools of measurement, such as his arm, his hand span, الشبر بتاع ايده, and the foot as a tools to measure length, and he using natural phenomena as tools of measuring time, like sunrise, sunset, and the moon phases. But it doesn't accurate tools to measure anything. So nowadays he was using a suitable measuring tools for measuring length and time and mass. For example, with the measuring tools for length, as we know, we can use ruler, meter tab, micrometer. We'll study micrometer in senior 3 inshallah, and something that called vernier caliper. We will using it on faculty of engineering. Okay. Second one, with the measuring tools for mass, digital and analog balance, Pin balance that we're using in markets and so on in Roman scale. So measuring tools for mass, digital and analog scale, digital scale, okay? Pin balance, Roman scale. For time, we're using clock, stopwatch, digital watch, and hourglass. Third, measuring units. When I said the mass of a boy is equal 5, the absence of a measuring unit makes us puzzled because we can't estimate the mass. Because it may be 5 kilogram or 5 gram. So the absence of measuring unit makes us puzzled. We can't understand the mass of a body. Okay, but when I said the mass of a body is equal 5 kilogram, so the quantity in this case is fully clarified. So we must put the unit in the end of our sentence. The mass of a body is equal 5 kilogram. My tool, my length is equal 164 meter. Centimeter. There is a number of systems to specify the measuring units of fundamental physical quantities, such as French system, British system, and metric system. Okay, what the units of measurement for length, time, mass for French system, British system, and metric system? First one, French system. French system, length in centimeter, mass in gram, time in second. To make it more easier for us, French system, everything is very small. So length in centimeter, mass in gram, time in second. Metric system or SI units that we are using today. Length in meter, mass in kilogram, and time in second. The British system, length in foot and mass pound, time in second. We are noticed that the unit of time is common in French system, British system, and metric system in second. So we must know the units of measurement for length, time, mass for the French system, British system, and the metric system. Now we'll talk about international system of units or SI units that we are using today. The physical quantity and the international unit. The physical quantity of length, meter, time, second, mass, kilogram, electric current intensity, ampere, the temperature, Kelvin, amount of material, mole, and measurement, radian, angle measurement, radian. Now we'll talk about multiples and fractions of units. When I said 100,000, it's very difficult to write such values. Okay, so we prefer to express this value in the form of power of 10. So 10, 100,000. We can read it 10 to the power 5. What did you do? You count the number of 10,000. It has 5 zeros, so it can put 100,000 in standard formula. 10 to the power 5. When I said 0.00001. In this case, we count the number of 0 and 1. So 1, 0, 0, 0, 0. So we having 5. It's called 10 to the power negative 5. When we have 0 point blah blah blah, we count the number of 0 and the number of 1. For example, 0.001. When we having 0 point any number, then we put 10 to the power negative, and we count the 0 and 1. So 0.001. So we have 0, 0, 1. So it's called 10 to the power negative 3. Now we will talk about Now we will talk about an important topic that called prefixes. To convert centimeter to meter, we must times centimeter 10 to the power negative 2. Hecto 10 to power 2. Millimeter 10 to the power 3. Kilometer 10 to the power 3. Micrometer 10 to the power negative 6. Mega 10 to the power 6. Nano 10 to the power negative 9. Giga 10 to the power 9. Okay, we'll give more examples to make it more easier, and it's a very important topic. Example number 1. A car moves a distance of 5 kilometers. Express the distance moved by the car in millimeter. Okay, first we must convert 5 kilometer to meter. So kilometer to meter we times 10 to the power 3. So 5 kilometer to meter equal 5 times 10 to the power 3. Okay, from meter to millimeter, as we said, millimeter to meter times 10 to the power 3. So meter to millimeter times 10 to the power 3. We move the negative. Okay, so 5 kilometer to millimeter to meter, 5 times 10 to 3 is equal meter. 5 times 10 to the power 3 meter to millimeter times 10 to the power 3. So 5 times 10 to the power 3 times 10 to the power 3 equal 5 times 10 to the power 6 millimeter. Okay. Another one, example number 2. The radius of a thin wire was measured by a micrometer was found to be 3 micrometer. Express the radius of the wire in kilometer. First, we must convert micrometer to meter. As we said, micrometer to meter times 10 to the power 6. So 3 micrometer to meter times 10 to the power 6. Meter to kilometer. As we know, kilometer to meter times 10 to the power 3. So meter to kilometer 10 to the power negative 3. Okay, we move the negative.